नमस्कार विद्यार्थी मित्रांनो, शशांक कुलकर्णी या यूट्यूब चॅनल आपलं सर्वांचं स्वागत आहे. विद्यार्थी मित्रांनो, आपल्या मागच्या व्हिडिओमध्ये आपण अल्किनचे प्रिपरेशन अभ्यासले. आज आपण अल्किन चॅप्टरतील अल्किनच्या प्रॉपर्टी अभ्यासू. तर सुरुवातीला मराठीत सांगतो तर समजून घ्यायचा प्रयत्न करा, नंतर इंग्लिश सांगतो. तर पहिले भौतिक गुणधर्म. आपल्याला माहिती आहे इथिन, प्रोपीन, ब्युटीन हे पहिले 3 मेंबर आहेत. कुणाचे? अल्किनचे. 3 मेंबर रूम टेम्परेचरला गॅसियस स्टेटमध्ये असतात. त्यानंतरचे ब्युटीनच्या नंतरचे 14 जे मेंबर्स आहेत ते लिक्विड स्टेट असतात रूम टेम्परेचरला. आणि बियॉन्ड द 14 ऑल मेंबर्स सगळे मेंबर्स कसे असतात? स्थायू रूपावस्थेत असतात. हा पहिला गुणधर्म. दुसरा गुणधर्म पाहिला आपण तर अल्किन हा जनरली पाण्यामध्ये विरघळत नाहीत. कलरलेस असतात, रंगहीन असतात, गंधहीन असतात आणि पाण्यामध्ये विरघळत नाहीत. तर ते नॉन पोलार सॉल्व्हंट, बेन्झीन, कार्बन टेट्राक्लोराईड यासारख्या कार्बनी संयुगामध्ये विरघळतात. तिसरा पॉईंट आपण पाहिला तर बॉइलिंग पॉईंट पाहू. आपण बॉइलिंग पॉईंटचा विचार केला आपण तर अल्किनचा बॉइलिंग पॉईंट हा त्याच्या वाढत्या अणुवस्तुमानानुसार वाढत जातो. लक्षात रेणुवस्तुमानानुसार वाढत जातो किंवा वाढत्या चेननुसार वाढत जातो. रेणुवस्तुमान जसं वाढत जाईल किंवा चेन वाढत जाईल तसा त्याचा बॉइलिंग पॉईंट वाढत जाईल. पण सारख्या रेणूमध्ये स्ट्रेट चेन आणि ब्रँच चेन अल्किन घेतले आणि त्याची जर आपण बॉइलिंग पॉईंट तुलना केली तर स्ट्रेट चेन अल्किनचा बॉइलिंग पॉईंट केव्हा पण जास्त असतो कुणापेक्षा? त्याच्या आयसोमरिक कंपाऊंडपेक्षा किंवा ब्रँच चेनपेक्षा. हा महत्त्वाचा पॉईंट आहे, लक्षात ठेवा. लक्षात. केमिकल प्रॉपर्टी विचार केला आपण अल्किन आणि अल्किन तुलना केली तर कोण जास्त रिॲक्टिव्ह आहे? अल्किना जास्त रिॲक्टिव्ह आहे. कशामुळे? डबल बॉन्ड असल्यामुळे. डबल बॉन्डमध्ये कोणता बॉन्ड आहे? एक पाय बॉन्ड आहे आणि एक सिग्मा बॉन्ड आहे. लक्षात ठेवा, पाय बॉन्ड हा सिग्मा बॉन्डपेक्षा केव्हाही विकर असतो. त्यामुळे अल्किन ह्या कोणत्या रिॲक्शन देतात? इलेक्ट्रोफिलिक ॲडिशन रिॲक्शन्स. तर यामध्ये आपण 2 रिॲक्शनचा आपण अभ्यास करू, हायड्रोजनेशन आणि हॅलोजिनेशन. हायड्रोजन म्हणजे काय? जर अल्किनवर हायड्रोजन गॅस पास केला रेने निकेल कॅटॅलिस्टमध्ये तर हायड्रोजन ॲटम्स हे डबल बॉन्ड ॲड होऊन करस्पॉन्डिंग अल्केन देतात. आणि हॅलोजिनेशन म्हणजे काय? अल्किन जर आपण हॅलोजनसोबत अभिक्रिया केली क्लोरीन, ब्रोमिन, आयोडीनसोबत तर ते हॅलोजन ॲटम डबल बॉन्डेड होऊन व्हिसिनल डायहालाइड देतात. लक्षात. याचा आपण अभ्यास डिटेल करणार आहोत. तर इथपर्यंत आपण ही 2 उदाहरण कोणाचे आहेत? इलेक्ट्रोफिलिक ॲडिशन रिॲक्शनची. द नेक्स्ट पॉईंट इन द चॅप्टर अल्किन इज द properties of alkene. The last video, previous video, you have studied the methods of preparations of alkene. Today I will teach to you the next point is the properties of alkene. The first property is the physical property. You know that the first member ethene, propene, butene are gaseous state at room temperatures. Beyond the butene, the 14 members are liquid in state and then higher members are solid in state at room temperatures. Next property, generally alkenes are colorless, odorless and insoluble in water but soluble in non-polar solvent like benzene, carbon tetrachloride, organic solvent. Third point, boiling point. If you take the boiling point of lower alkene to higher alkene, if you go from lower alkene to higher alkene, then boiling point also increases with increasing its molecular weight or with increasing the chains. But if you compare the boiling point in between the straight chain and branch chain, for example, if you take the straight chain alkene is the butene, CH3, CH double bond CH3. That example of which butene? Straight chain, N-butene. If you compare the boiling point of this butene and same isomeric compound is the CH3 double bond CH. It is an CH2, the isobutene. Generally, the boiling point of N-butene is higher than the isobutene because N-butene is a straight chain alkene. Remember, always boiling point of straight alkene is higher than the branched alkene. Next point is the chemical property. Remember, the alkene is high reactive than the saturated compound because alkene contain the double bond. Carbon double bond present in the alkene. Out of this double bond, one is the pi bond, second is the sigma bond. You remember one very important point. All pi bonds is weaker than sigma bond. Therefore, pi bonds easily lose or break the bonds and share the electron on the bonded carbon atoms. Therefore, alkenes undergoes the electrophilic addition reaction at a normal condition. This is a very important point. Generally, alkene undergo which reactions? Electrophilic addition reactions. For example, first is the hydrogenation or catalytical hydrogenations. Hydrogenation, or it is also called as the catalytical hydrogenation. What is by catalytical hydrogenation? When hydrogen gas is passed on alkene in presence of platinum or palladium. If you take the platinum or palladium as a catalyst at room temperature, this reaction takes place at a room temperature, or if you take the raney nickel, then the reaction takes place at a high temperature. This is a very important point. If you pass the hydrogen gas on the alkene, then hydrogen atom is added on the double bond carbon atom and to form a corresponding alkane. For example, when hydrogen gas is passed on ethene, H2 gas is passed on, then what happens? Pi bonds are break and hydrogen atom is added on the double bond carbon atoms and to form a CH3 bond. CH3 is the ethane to form a saturated compounds. Second example, when hydrogen gas is passed on propene, in presence of nickel, raney nickel as a catalyst at high temperature. What happens? Which reaction takes place? Electrophilic addition reaction takes place, means hydrogen atom is added on the double bond carbon atom and to form a saturated compound CH3, CH2, CH3 propane. Therefore, this reaction is useful for the preparation of alkane from the corresponding alkenes. I understand. Next, second example of electrophilic addition reaction is the halogenation or addition of halogen. Addition of halogen is also called as the which reaction? Halogenation reactions, known as the halogenation reactions. You remember here the order of reactivity of halogen. Reactivity of halogen is chlorine is more reactive than bromine, bromine is more reactive than iodine with a alkene. For example, if you take any halogen, if the halogen is added on alkene, then what happens? Pi bonds are break and electrophilic addition reaction takes place to form a corresponding vicinal dihalide. What is by vicinal dihalide? How to define the vicinal dihalide? When the halogen atom is attached to adjacent carbon atom, such dihalides are called as vicinal dihalide. And if the halogen atom attached to same carbon atom, the molecule called as the geminal dihalide. For example, when chlorine is react with ethene, or chlorine gas is passed on the ethene in presence of carbon tetrachloride solvent. What happens? Chlorine atom added on the double bond carbon atom and to form a CH2Cl, CH2Cl. You see here, this two halogen atom attached to which carbon atom? Adjacent carbon atom. Therefore, it is called as vicinal dihalide. Name of compound is the 1,2-dichloroethane. It is an example of which dihalide? Vicinal dihalide. Second example, when propene is react with bromine, Br2, in presence of carbon tetrachloride solvent. Remember, the color of bromine is reddish brown, red brown or reddish brown. When bromine molecule react with any alkene, then this color, red brown color of bromine disappear. This is very important point. Remember important point. Which color disappear? Color of bromine disappear fastly and to form a vicinal dibromide. Therefore, this bromination reaction is useful for the detection of unsaturation on double bond present in the alkene or not. How will you conclude double bond present or unsaturated present? If the color of bromine disappear, then we conclude that the given hydrocarbon compound or molecule contain the unsaturated double bond. And if the color of the bromine is not disappear, means addition reaction not takes place due to absence of double bond. Therefore, when propene is react with bromine to form a CH3 CHBr CH2Br. Name of compound is the 1,2-dibromopropane. This is the IUPAC name, common name propylene dibromide. This is also an example of piscinyl dihalide. This reaction useful for the detection of unsaturation or double bond present in the alkene or not. I understand. But iodine do not react with a alkene at room temperature. No reaction, or we get a small yield or less yield, no reaction at room temperature. It reacts with a drastic condition because the reactivity of iodine is less than the chlorine and bromine. I understand. Which type of question may be asked on this point in the examination, that will be given in the description box below the video, and some important points or notes also given in the description box. Thank you.